So let's consider a question. An example. Compare electron density in the ring. Compare electron density in the benzene ring. So we have given four options. A is fluorobenzene, B is chlorobenzene, C is bromobenzene, and D is only a benzene. Okay, neither any functional group nor any substitute attached with that. So now we have to compare the electron density in benzene ring. So now we know that if a fluorine group and an halogen is attached, when an halogen is attached with benzene ring, so it has lone pair. We know it has 3 lone pair. Okay, now due to this lone pair, it shows what effect? Plus M effect. And it is also electronegative. It is also electronegative. So when it is electronegative, it shows minus I effect. So it shows 2 effect, plus M effect and minus I effect. So we know now after experiment we got to know that it decreases the electron density in the ring. It decreases the electron density in the ring. So overall it decreases the electron density in the ring. So it has 2 effect, plus M effect and minus I effect. So if we see the order of plus M effect, what is the order of plus M effect? We know fluorine greater than bromine greater than iodine. Okay, why fluorine has the most plus M effect? Because the carbon directly attached with it belongs to 2p shell, and the fluorine belongs to 2p shell. So bonding is here 2p bonding. Here bonding is here 2p 3p bonding. Here bonding is here 2p 4p bonding, and here bonding is here 2p 5p bonding. So most effective bonding. This is most effective overlapping. When there is resonance, so it is most effective overlapping. So plus M effect of fluorine is greater than chlorine, bromine and iodine. Now if we see further, if we talk about minus I effect, we know minus I effect depends on electronegativity here. Electronegativity. So if we talk about minus I effect, the fluorine is more electronegative than chlorine, than bromine, than iodine. Fluorine, bromine and iodine. This is the electronegativity order. Okay. So now if we see further, now let's see. We have two options. One is plus M effect and one is minus I effect. And we have seen overall it is electron withdrawing effect. It decreases the electron density in the ring. So now if you see fluorine, if we talk about fluorine, and if we talk about chlorine, now we know that fluorine, let's say plus M effect and minus I effect. It has 2 effect, and it has also 2 effect, plus M effect and minus I effect. So now let's say it has plus M effect. So plus M effect means it is pushing the lone pair. It is pushing the lone pair. Let's say it has the magnitude of 14. Okay, and minus I effect, let's say it is 7. It is pulling electron by 7 magnitude of force. Now if we go to chlorine, we know that plus M, here it is 2p, and here it is 2p 3p. So there is a very big energy gap between 2p and 3p. So we know that plus M effect will reduce gradually. let's say it comes down to 7 magnitude, and we know that minus I there is not much gap. Okay, so let's say this magnitude to be 16. Let's say minus I effect is 16. Now we know plus I effect have reduced to half because there is a very big energy gap. But minus I effect will not reduce too much. So let's say the energy magnitude is 14. Now let's see once again. Plus F effect showed 2 effect, plus fluorine showed 2 effect, plus M effect, and minus I effect. And chlorine shows 2 effect, plus M effect, and minus I effect. We know that fluorine, this and this bond has 2p and 2p, but here it is 3p and it is 2p. So we know that that plus M effect will reduce very much. 14 it reduced to 7. Now minus I effect for fluorine is 16 and here chlorine is 14. Minus I effect won't reduce much because fluoro, chloro, bromo, iodo, it decreases down the group. Okay, decreases down the group. So the magnitude change is not much. So if you see overall effect, so overall effect here it has reduced by 2 and here it is reduced by 7. So as we go fluorine, chlorine, bromine, iodine, the minus I effect reduces. Okay, the electron pulling tendency reduces. So if we see overall order is first of all D, then A, then B, then C. Because fluorine has less pulling power, so it reduces less, so it decreases less electron from ring. So that's why the order is D, A, B, C. Now let's see further one more example. We have a structure, a compound, and we have a different resonating structure over here. Okay, what could the possible next resonance here? If you shift the lone pair here, so you will get one more resonating structure. Now we can get one more resonating structure when we shift the lone pair to that side, right hand side. So we have total 3 resonating structures. Now let's give their name A. Let's give them name A, B, C. So now if we want to calculate the stability, so it is, if we see if you see here, it is first of all we will, what is the rules of check the resonance stability? First of all we will check all are neutral or not. So here no one is neutral. Now come to next point, that octet of each atom should be completed. So here it is incomplete, here it is incomplete because carbon plus has 6 electrons. Okay, it has 6 electrons, so it is incomplete. Here it is complete. So C is the most stable. We have to check the stability. So C is most stable. Then if we come to between A and B. Now if we come to A and B, if we say A structure has continuous resonance. Okay, A structure has extended conjugation. Okay, A structure has extended conjugation. Then we come to B. So it is, answer is given by octet complete. A is having extended conjugation, and B is having cross conjugation. Extended conjugation and cross conjugation. Now let's see one more example. We have a structure CH2 and CH. This type of aldehyde we have, and we have its resonating structure, one more CH2. Again we have to check their stabilities. So we know that first of all, first point we will check that all the structures have complete, so all are neutral or not neutral or charged. So we know here all the charge. Let's come to second point, octet complete. Yeah, everywhere octet is complete. Let's come to third point, octet complete. After we have to check bonds are similar. Yeah, bonds are similar. Now we have to check if charge is there, then positive charge should be on less electronegative and negative charge should be on more electronegative. So if we compare here, the negative charge is on less electronegative and positive charge should be on more electropositive. So that's why B, if we give the name A and B, we know B will be more stable than A, because here negative charge is on more electronegative, here negative charge is on less electronegative. So B should be more stable than A. Now let's again talk about minus I effect, minus M effect. Order of minus M effect. Order of minus M effect. So if we talk about order of minus M effect, we know that the positive charge should be, if A has positive charge, should be more than A is neutral, because minus M effect means pulling power. So A is electron deficient. A is electron deficient. So here it is CH2 plus. If we see the order, CH2 plus, then electronegative elements will come here, then cyanide, then aldehyde, then ketone. Okay, so this is the basic structure of the order of minus M effect. If like some other compound is there, so we have to see comparison according to this order.